So good morning to all. Myself Azamathulla from University of the West Indies, Saint Augustine. Thank you for attending this course. Mehta sir has conducting several webinars. Past year I am observing is attending and conducting. So today I am going to talk about application of soft computing techniques in hydraulic engineering. Before that, several examples I will show why we need soft computing. Okay. So you can see this picture, hydraulic models spillway in Central Water and Power Research Station, Pune, Kadakmatla. It's almost 20 years ago. I have conducted the studies. This is my first project. After I was working in National Water Development Agency, New Delhi. I worked 1 year, 4 months there. My boss, Khurana sir, sent me here CWPRS, and I did simultaneously my PhD from IIT Bombay using loss of pay leave. Okay, see here you can see model and prototype. Why hydraulic engineering needs model, and why neural network soft computing models useful, I will show today. Okay, you can see here several I have several collaborators. You can see Iran Water Research Institute. You can see several model studies. Okay, that's why I have so many problems. Problems and papers. Okay, so simple way. Today I am going to explain about spillway. Why we need spillway? To dispose floodwater in excess of reservoir capacity, to control discharge over spillway by gated operations. Okay, so any spillway in operation due to high velocity jets, scour takes place. This is a natural phenomena. Mehta sir also published several papers, so he know about much about scour. So he is doing Hecras. Okay, here you can see. So what type of energy dissipatory will provide? Normally we have stilling basins, we have trajectory buckets, also we have schism buckets. Schism bucket in India we call, trajectory buckets in Europe, flip bucket in America, they will call. So what type of energy dissipator to maintain this super velocity flows? Okay, super velocity flows. Score takes downstream of spillway here. See, you can see score takes place. Is 5 here, you can lip angle. This is bucket radius. Q is small discharge intensity or specific discharge. So here I need to find out location of score, so that my main structure will be safe. So here you can see TWL, tile water level. This is depth of tile water depth. This is core depth. So original ground level. See here, you can see major. See head one, H1. So reservoir level to tile water level. In case of Damle, he mentioned H only until lip. Okay. So to protect the how to protect to how to save this safety design. Score occur downstream of lip of the bucket. So several times I will show you now to prevent uncontrolled score on river bed and banks. So two alternatives are available only, either pre-excavated plunge pool here. Another one, we can raise tile water level downstream, mm, sufficiently downstream side. We can to construct a weir sufficiently to raise tile water level, so that whatever jets coming impact due to impact. But here you can see here. So estimation of score can be classified in 4 categories: theoretical analysis coupled with laboratory investigation, theoretical analysis coupled with prototype observations, empirical relations based on prototype observation, and laboratory experience. Here, so what is the main problem here? Earlier researchers, see, you can see almost 8 decades, Werner's used only discharge intensity and head. He, he produced one formula. Another one, Damble sir have in 1996, he also Q and H only. All these authors used only 2 variables to predict, and also they give only depth of score alone. They never ever gave location of score or width of score. Okay, width of score. So here, in case of Ukai Dam, maybe in Gujarat only, I don't remember whether in Rajasthan or Ukai. So Werner's formula predicting 18 meters, while observed score was 27.4 meter. In case of Rana Pratap Sagar, Werner's formula gives 18 meter. Okay, so uh, actual observed 25 meter almost. In case of Kariba Dam, you can see Werner's formula giving 42 meter. So Actually, you can see Kariba Dam each year, each 5 years, it's more than dam height going. So 100 or 20 meters dam height, so almost reached score level. So this is now many US dams, so they are removing. Okay, so Bureau of Indian Standards they adopted same USBR formula, they adopted weirdness formula. So this is the formula they had to do. So till now in India they are using only this formula using discharge intensity and head. So mechanism of score unknown. So whenever problem is poorly defined, Manning's, several what Navier-Stokes equations. So much variables have to come. This one computational fluid dynamics cannot solve these problems. So that time I worked with, under Professor Dev, MC Dev from IIT Bombay. That time the neural networks I have used. These are the some literature survey I have made that time. So it's actually electrical engineering. They have in voltage stabilization. So slowly in 1990s, 91, 95, 99, so in civil engineering also we are using. Okay. So now some algorithms I used. There are evaporation algorithm. So I have used. So here three layers available. One is input layer, another one hidden layer, another one output layer. Here error is of propagation towards goal. Okay, so another algorithm I used cascade correlation algorithm. So here hidden neurons are adding one by one till your target achieved. I will show you another one radial basis function I used using MATLAB. The earlier two I used SNSS software those days. Nowadays no matter these students are using MATLAB. Okay, so that time so ANFIS program. See, large number of equations have predicted ultimate score depth. Ultimate means there is no further score or equilibrium score. Many equations simply ignoring some important factors like tailwater depth, lip angle, bucket depth, bucket radius. Why bucket radius? Rate of change of momentum equal to force means whatever force means high velocity jets. So those values should be considered. So less attention paid by previous authors. Okay, so I must give some geometry. So I have given score depth, score width, and location of score, especially location of score. I will show some of my papers to you. Hmm. So data on score geometry I have collected several model studies I have conducted in CWPRS, Central Water and Power Research Station. Also the previous studies observations I have managed to. So also I have collected some prototype observations means 93 dams all over the world. So where data available only depth of score, discharge intensity and head, only three. There is no rock mass data, rock quality designation data. So that time, so whenever problem is poorly defined, so neural network take advantage. This is the advantage, data driven nature, model free from any predictions, so any error tolerance. So I have used some neural network problems. Okay. So here clearly mentioned, you can see I have provided these slides to Dr. Mehta. Okay. So some objectives I have conduct some studies. I have several new studies: Dhauliganga, Parbati Dam Spillway, Nath Pajakari, and Seva. I have personally conducted. It took 5 years to get PhD. Okay, several studies, and also I have performed with several formulas and several architectures. Okay, so here, so regression models. Earlier, any before going to any designer need regression equations, non-linear regression equations. So that time I will total 95 data sets. So I have taken as inputs as a discharge intensity, head, tile water depth, lip angle of the bucket, radius of the bucket, particle size, bed material. Since here the one of the problem is you may ask, always we compare model and prototype. This is the everyone having problem. Since in model we use sand 2 mm or 3 mm, but in reality I will show some slides. So reality very huge boulders in what, but scoring pattern and location it will exactly behave. Exactly behave. Okay, behavior same. Okay, this is the model study I have conducted. You can see score downstream of spillway, Parvati Dam spillway. It's three spans. Okay, here you can see why score takes place. You can see always to power generation gamma QH. So your head will be very high. You can see also here the sluice type spillways. and breast wall type spillways. My boss, Bhasekar madam, has done PhD on that. Okay, see, you can see upstream view. You can see this is the breast walls, breast wall types, breast wall 1, 2, 3. So you will get this one. So your power intake. Your power intake. So you have to have maintain full reservoir level. The other day I was interesting. Professor Yadav was explaining storage how rule curves, chance constraints. Okay, so you must maintain. So the same thing. So the reservoir rules. So to maintain full reservoir level, then only your power intakes will operate. Okay. So gamma QH. Although you have to at the same time you have to operate. If operate means you can see huge jets. See. So you can imagine in model only this much jet. Here you can see the jet was hitting right bank. So we suggested it's the only option. You cannot change the nature. What we have to change ourselves. So we suggested that time change this dam axis so that the jet will be normal. You can see here. So here different flow conditions I have and I have collected. So you all aware in second year level Buckingham pi theorem. So depth of score is function of these are my variable discharge intensity, head, bucket radius, lip angle, tile water depth, and bed material size and gravity, density of water, density of sediment. Similarly, location of score. See, after Buckingham theorem, some repeating variables I have considered. Sorry. So, okay, now working. So, now. Here something pi theorem, non-dimensional equations, non-dimensional equations in the form of this is a fault road number. You can see this fault road number relative head with all with respect to depth of tile water level. Why? This is your if you have your depth of tile water, then your score will be maybe less, more water. So we will see how. So I have derived with some 75% training data. These are my coefficients, powers. You can see. You can see. Please see. All observe. So much. The same way I will prove in neural network. So you cannot see any neural network papers. What I am going to show you today. See. So relative importance. What is the relative importance for fraud number? 69%. Please note down this. Can later on I can show you. In case of C here. So perhaps this paper also I will show you location. Perhaps you have studied jets x means maximum range of jets x square sine 2 theta by g. So your phi will be more importance. Okay, you can see more importance. Okay, same way. But in case of lateral dissipation, some formula failed. You can see inverse relationship. You can see this is due to. So that's what we give some formula anything. So anything is meaning correct. That time some comments also I think SK Mujumdar wrote some comments on so why we got negative, why we got negative, why we got positive. So any time if you publish any paper, so already people are aware and they want to pull our carpet. Okay. So uh, any model, how we decide which model is good? There is a correlation coefficient, means observed versus predicted values. Okay. Correlation coefficient or coefficient of determination. Another one, root mean square error. Another one, average error and mean absolute deviation. Okay. Average absolute deviation. Okay. These are the my values. You can see here correlation coefficient is still okay. So my regression equations are failed almost. Okay. So I have used these are my scatter plots for my regression equations. Okay, observed versus predicted. Okay, although only location of score is perfect, little bit high, good. Okay, so you can see. Okay, location of score, this one very good. Now we'll see. So yeah, now I will show why this problem is very important. You can see this beautiful dam in Srinagar called Salal Dam Spillway. After then the time Prime Minister I don't know name. So after he inaugurated this jump operation, what will happen? See here. Okay, they operated till in one day 24 hours. This many cusecs cubic feet per second. What is the situation? You can see. So they did not notice that, then simply neglected. What will happen after operation? Okay. So whose fault is this? Designers, or hydrologist who decided this much? So you can see full beautiful dam. See our dam. Okay. So score takes place. So another case I will show you. This one Srisalam Dam in Andhra Pradesh. I belong to Andhra Pradesh. See here, lip angle made blender mistake. Only 35 degrees or 30 degrees. You all aware in high school we have studied maximum just x square sine 2 theta. If theta 45 degrees sine 91, so jet will go very far. Okay, so less radius means rate of change of momentum equal to force. So less rate. Very less radius. So here every year they have problem. So one day this dam will collapse. No doubt about that one. See, you can see very dangerous jet. This is Srisalam Dam. Okay, these are the blunder mistakes they made. So these are the some prototype data. So why we need to go see is there any relationship with this core depth versus discharge intensity? Highly random means there is no relationship. So why we are using neural network model? This kind of things. Once regression also maybe fail. So head versus again same. Okay, there is no trend. Okay, so that time I collected all prototype data. I did two inputs and two hidden nodes in one layer and one output. Only depth of score. I don't have any other data with location. For this one, talking about prototype data. Okay, so I managed to same thing using this Stuttgart neural network simulation, feed forward network, feed forward cascade correlation, radial basis function, and FIS. I used that one. I will show new software. So these four traditional predictors. So those you can see those correlation coefficient from them, and you can also see this. So neural networks have capability to predict. So I will show you now. So I also derived one of the equation very similar to INSIT. This INSIT, and regression means mean. See, almost good. Since I have used more data and data range, this all how it will work. Data range and neural network. First thing is another thing. So you know the processing, how you will need to process data in neural networks means all are equal. Like in your college, your college is uniform, right? So otherwise, what will happen? This bias and yes, bias and weights inputs multiplied weights plus bias, it goes transfer function. That's why neural networks always we need to do normalized data whether between 0 to 1 or 0.228 up to you. In MATLAB mostly -1 to 1. Okay, without normalization means if method came, no, if any minister come, we all method in his son. So weightage correct. So that's why here also same logic means this is nothing but neuron means what? Information processing element means sometimes trained. So method no, I will be available, otherwise I give time and I sleep. No, his mind told means his mind, it's how it works. Your human mind, how it works same, it's mimic very similar. So here whatever data you give, it will absorb. That's why I have used it for this Spillway scores. Okay, whatever data you give, it will show. I will show you trend. Okay, so this is prototype. So you can see here exactly same as in the same as the author. See, yes, also important. We always see this one. So why if not so why? Okay. Some of the error measures. This paper I published in IIHR. I will show you very good journal. It took 5 years. Unfortunately, they misplaced. So another all my results I will which I am going to show you. These results I have published in ASC Hydraulic Engineering. Once you publish two papers, then no problem for PhD. So you can see this looks like continuous model. Otherwise in CFD also it's not. I will show you that also how my Iranian student worked. Okay, these are the inputs raw variables. See here in this is 6 raw variables and 6 nodes, hidden nodes, I mean hidden neurons, and 3 simultaneously continuously I run the model. I wrote programming here in MATLAB programming. Okay, if anyone interested, ask Dr. Mehta. I will give you. Okay, using this one model using raw variables. That time Liriano and Day published for Calvert scores. So I have used the same methodology. That time it's published. That those days very difficult to get papers. IIHR very difficult. So fortunately our director was purchasing. Then I got that paper. Now after means any paper published in hydroinformatics, after two years it will be free. Now you have a lot of access. Okay. everywhere. So another model, see, grouped variables means it's the same dimension analysis I derived, right? Those Proud number, then relative head, relative bucket radius, everything related to relatively, relatively your depth of tile water level. Here also you can see everything, the relatively, relative depth of score, location of score, width of score. So since this model is continuously running, right? So it should capture a mechanism. So these are the hidden neurons. See, in MATLAB, those time very fast, very fast. For prototype data, you should get neural networks. Is the radius function. You close eyes and open, it will finish. Even if you want, I don't have MATLAB now. I can show. So long back age, okay, neural network model. These two. So many people. So these results I have published here. See, cascade correlations giving very good. Only the problem is it won't give any equation, but we will see how. So these are the results I have produced that time. Okay, this model I have recommended that time. Okay, and then your answer weights. Okay, so significance. So what we need to do now, which parameter is namely 3. Okay, now you can see here. So I also do some sensitivity analysis that time. So initially only two traditional, all authors are using these two, so I used how much is. Finally I have used all variables here, all variables, so I get the highest correlation coefficient. Okay, even in case of C, almost 1. If 1 means your supervisor in anyone will suspect, but MATLAB it will show that time location of score. Okay, here since it analysis I have done. Okay, then previously I used raw data, now I am using grouped variables. You can see grouped variables. Okay, grouped variables. Then if you use, I use all variables, what will happen here? Okay, here no phi, here phi also included, so almost 1 it's getting. See, please see everyone, so the results. So connection of weights here. See, the some techniques I have used in weights and bias, very calculations. Very, so weights I capture in MATLAB. Then again using weights, runs, compute importance. Please see here relative importance of Q. H1 means head, bucket radius. So this kind of capturing means the knowledge extracting from trained models. I will show you now. Okay, the another model you can see here. See how much importance, relative importance, right? Any equation if you derive from regression, you will also see. So this is so neural networks also proved. Yeah, so mostly many papers you never saw this one. That's why everyone criticizing neural networks have disadvantages. Okay, so some parametric studies also I have done. So you can see here keeping all inputs, but one as a constant at a time. So this one, that time very difficulty. You can see proved. You can see this one q, if more q, more score. If more head, more score. More bucket radius, more score. So if bed material, so inverse relationship, right? If more bed material is more strong enough, so you will get less cover. So it's proved already. Okay, so some perturbation analysis also hidden means your data have some noisy data, some error have 10%, 20%, how it will work for your correlation coefficient. Okay, this one you can see nowadays. Some recent authors, they're drawing, like more diagram, that diagram, this diagram, almost same meaning, same meaning. So if you can see now 10% error, you will get less correlation coefficient. See, less correlation coefficient. Okay, my time, no, that time anything we cannot bluff. They will ask, show me everything. We have to run the program, need to show. Okay, so this is the, so without perturbation, see, you can see this is the correlation coefficient. So how if minus 5%, 10%, how it decreasing, decreasing. See here, decreasing. So this is the thing I have done. This I have not published anywhere. I did not publish this one. So some correlation coefficient with hidden neurons. Okay, each neuron. Okay, so again, I also used that time, neurophagy means neural networks plus fuzzy logic. Fuzzy logic means if then else, how your washing machines are working, how if you go any restaurant, how much tip you will give if food is good, hospitality is good, and furniture is good, infrastructure is good, then you will happily will give. If one thing is bad, so you will not give anything. So same thing. So then else, so some fudgy inferences. Okay, so how it's working, this one Jade developed Sujane type, this one available in MATLAB, so you need to do MATLAB NN tool. So here whatever recommended model, again you need five inputs and one output at a time. Okay, here I cannot use same as like neural network. See the difference. Earlier I used my model output, depth of score, width of score, location of score. Now I can't here. No? So that time I used the rules. I will show you some other papers. Okay, so these are the rules. I gave two rules and one output only. So again same type used for another two also. So these are the results I got. But ANF is perfectly worked. Those are the conclusions. See, all formulas are gone out. Why they used only Q and H? Only two. Well, they never thought about bucket radius or bed material or something, right? In the model is model means continuously starting to end. Okay, so these are the things used at that time. Okay, recommended model that time. So also validations. Really, this published in AC Hydraulic Engineering. Also another paper published in Advanced Engineering Software. I will show you several papers now. Okay, so these are some conclusions. These are some conclusions. So that time I never, if anyone interested, means if data available, they can do means considering rock quantity designation. Okay. And three publications that time. Although I have many papers. So this is the geometry in physical geometry physical model. See, physical model, gated flow and free flow, two types of Parvati dam spillway. Okay, now I'm talking about some little bit only. I will talk about today. If Dr. Mehta conducted one more lecture, that time we will talk about why soft computing in since more than half century. It's very useful in hydraulic and electrical engineering, even mechanical engineering. So whatever complex relationships, it's easily you can derive. This is, actually, this is technique to neural network means what my professor said, technique to map random input to random output. Okay, so absolutely models are trained very properly. These are the some backgrounds. Okay, so it's also same optimization everywhere, optimization techniques only. So some models nowadays I also use support vector machines, but everywhere once you don't provide any equation, any design formula, so designers, no one will happy. So that's why nowadays we are using gene expression program. I will show some directly some papers. Okay, some problems I will show you. This all theoretical. I asked my student, he prepared so many, but I don't want to go to some mathematics in Fuzzy. So SVM also, I also don't like much, but gene expression programming, this will give exact. This is nothing but same your technique like regression technique. It's actually revised. You can once you use GP software, you will come to know almost like regression type only this one. So how derive the initial stage generations and all. Okay, so one of the my student have done for score below, pipeline. Okay, and based models. I will show you those. So some examples he gave. My student prepared for any civil engineering. That's why I am skipping. Yeah. For predictions, few I and I thought when also published. Same also I have published several papers. See this one. I thought when after my PhD, during my tenure in Malaysia 2007 to after postdoc, I thought when so he published with me several papers on score, especially GEP. You can see any paper our name there, and we got several citations also. We got so much money also. Means if you publish high impact factor in Malaysia, they will give a huge amount. I also managed to publish the US GS chief, Dr. Ardija, but he was my commenter. Means all my papers he will be suggesting, he reviewed and he helped a lot. Another one, this one, I think Aligarh University professor. Okay, here, for the even score also they also using. Okay, so this one still they are using. So some another grass bulletin traps also I have used. Okay, now I will show you. I will show you before wasting your time. I will show some of the papers. Some of the papers which I published. First paper I will show you. ASC hydraulic engineering. See, please see one by one. I will show you. Hydraulic engineering in 2010 I managed to publish. You can see GNT programming. This paper got the same score, same technical, especially like second year level only. We are not going much. See here, only Buckingham pi theorem, some sensitivity analysis, everything same. This one the task score derived somewhere some mistake, then I don't know. So I derived this equation also, regression equation and traditional equation. You can see here, always you can see, observe any XIII hydraulic engineering center, maybe Dr. Mehta so much talking about heck ras, heck. See that one, they used only two. See, they never bother about other variables. You can see, I think this one proved. That's why this it's paper published in hydraulic engineering. You can see always any formula, only two or something. I don't know. Still they're using HECRAS and Federal Highway Administration circular numbers so you can see. So I have compared see HECRAS, sorry HEC18 formula. So how much their formula, their so writers HEC18. So we have see always some, as I told, maximum and min range. These models all works in range only. Like Dr. Mehta trained me car and bus, but he cannot ask me drive or to fly an aeroplane. Okay, so range is most important. Data set range is more important. This kind of models. Okay. Okay, yeah, range, yes, please see training and testing range. Yeah, yes, see, I told, right, training and testing range, how much. So 350 data sets from US bridges and collected at that time. You can see.
Sir,
Yes,
sir, are you
hello,
sharing your paper on your screen?
not coming.
No, sir. Only your PPT is visible to everyone.
uh, oh, sorry, how to
So
share.
so you have to share the paper
Acha,
same
let's,
as that you share PPT.
sorry, I closed PPT. Okay,
Yes.
that one better. Now yeah, why don't you tell me, Nita sir? Now it's
Wait,
coming.
no. Please do share content again.
Okay, sorry. Oh, yeah, I will show you now again. See here now, are they
No,
visible? Hmm?
not visible, sir.
अरे किधर चले गए मैं? अच्छा, okay, I need to go here. Yeah, sorry. Now, yeah, now, Doctor. Hello.
Wait.
Now coming,
Yes,
right?
now okay.
So yes, I can see. Please see. I'm really sorry, extremely sorry. Uh, so yes, now I will show you. See here, slowly I will go. So this paper, you can see what I was showing to you. Data range. You can see data range. Okay, this will work only within range. This kind of models. Please note that one. Another thing, what I was talking about. Yeah, I was highlighting. So here, please see this one we compared with HEC 18. They also used here, see, please see only two variables. Okay, relative depth of score means y is flow depth, y is flow depth. So here see. So same. Okay. So see kind of equation we got several citations, and this is in hydraulic engineering we managed to publish. Okay. Also next paper, yeah, this one advanced engineering software. Please see for using only prototype data. If anything not audible, tell me, Dr. Mehta. Can you see? Or no? Hello, hello, Dr. Mehta.
Yes, sir, it is visible.
Which one? Advanced engineering. See, you can read.
No,
Please see.
no. The first paper. Look, first paper which you
Not
have
that
said.
one. Okay,
Yes.
I must close. I must close that one.
Yes.
Oh my God.